Okay, so how's everybody doing today? Okay, good to hear it. There's a lot to do. May not be thinking about it, but next Thursday is the last time I will see you folks. That is our final. I mean, next Friday is the end of school. We are down to the wire. We have our last grades coming in this week. So especially if you're a senior, you are going to be finishing up even faster. You're going to be taking your finals on Monday and Tuesday of next week. So Tuesday is your last day next week. You'll have some meetings to come to, but you'll be informed about those. But definitely try to take care of everything as soon as you can. So let's just go down my list here. First off, there's still AP testing going on, and Wednesday morning they're going to be using our room here for, I don't know what test it is, but they're going to be testing in here. So on Wednesday during third period, we are going to meet in 2101. I don't know whose room that is. It's down the far hallway over there, just off the main second floor. So if you do forget, I'll have a sign on the door. I'll go ahead and remind you again tomorrow when I see you guys. But we will not be meeting in here on Wednesday. Okay, now tomorrow I will be here for tutorials, but I may need to go ahead and cut those a little short. Both today and tomorrow, my IB kiddos are taking their paper exams. Today it's at 1 p.m., but tomorrow it's at 8:15 in the morning. So myself and Mr. Heinrich need to go and make sure all the calculators are cleared before they can go ahead and take the test. And I need to go ahead and do that before they start at 8:15. So I will be here. I just will have to cut it a little short if you are going to come in. Okay, so that takes care of that. What else do we have here? We are about to look at our focus activity. Now, this is the last focus activity for this set. You're going to be turning in numbers 3, 4, 5, and 6. I mentioned just a moment ago, I've got number 5 right here if you need it. That's going to be due on Wednesday. Because we're not even in the class on Wednesday, I'm just encouraging people to turn them in as soon as you can, either today or tomorrow. Satish?
So we're going to be gone on Thursday.
Mm-hmm.
Are we going to grade time?
No, the test is on Friday.
Oh, okay.
Test is on Friday, yes. So I'll get to that in just a second. Okay. Now, one thing that's due tomorrow is going to be the parametrics assignment. So if you were gone on Friday, a lot of people got my remind text, swung on by and picked up a copy. Thank you if you're one of those folks. If you didn't do so, hopefully you went to the website. I got extra copies over here on the door. But even if you were absent on Friday, it is still due tomorrow for you. Okay, so please get that taken care of. And then Satish brought up the test. It is on Friday, Friday the 17th. What will it cover? Two concepts. Parametric equations and not polar coordinates, hyperbolas. More than likely, we are going to finish up this first lesson on polar coordinates, but I didn't put anything like that on the exam. Okay, so hyperbolas and parametric equations, that'll be Friday. That's going to be worth 15%. It's not a lot, but it's the highest that a grade can count, especially for the seniors. That's going to be your last grade of the year. We want to make sure it's as high as possible because grades are finalized Monday and Tuesday because your graduation is next Friday. Okay, we've only got 10 days of school left, and 2 of them are half days. So we are getting down to it. I think that's everything I have, unless anybody has any questions about what's coming up. Okay. I'll go ahead and talk about the final real fast. Like I said, next Thursday is when you guys will take your final in here. I'm going to work it the same way we did at Christmas. I'm working on a review right now. It's all multiple choice. It's concepts from throughout this semester. And I don't remember how many I put on the review so far, but I'm taking 10 of those exact questions, and that's going to be your final. So if you feel 100% good about the review, come in here. That final should take you less than 30 seconds, in theory. Okay. But if you're a senior and you're taking it Monday and or Tuesday, I think the way it works for seniors, they haven't said anything about it yet, but last year the seniors took the odd number period finals on Monday and the even numbered periods on Tuesday. So I'm guessing they'll probably keep it the same, but they may go ahead and change it. I don't know. I'll let you know as soon as I know. I will try to get that review to you as soon as possible so you guys can start looking at it. But yes, ma'am.
it's first through fourth Monday, and then your other class.
Well, now I know that for everybody, it's 1st through 4 on Thursday and 5 through 8. Have they changed it to?
My forensics teacher sent out like a thing for next week.
Okay,
First
let me double
Monday.
check on that because I know in the past that's what they've done. So I'll double check to make sure. Okay, because I want to make sure you have the right information. But I think that's all I got. Unless anybody has any other questions. Finals, test, focus activities. Okay. Well, let's go ahead and get going because I do want to give you a little time in class today to go ahead and work on your parametric assignment. And this right here, focus activity number 6, it is the final, the absolute last focus activity of the school year. So it kind of brings a little tear to your eye, doesn't it? It's the end of an era. It's bigger than the Infinity Saga. Okay. Wow, it's really quiet. Okay. Number 1, in many U.S. parks, campers must secure food and provisions from bears and other animals. One method is to secure food using a bear bag, which is done by tossing a bag tied to a rope over a tall tree branch and securing the rope to the tree. Suppose a tree branch is 30 feet above the ground and a person 20 feet from the branch, we're talking horizontally, throws the bag from 5 feet above the ground. Okay, so this problem relates to the formulas that I introduced on Friday. We've got some projectile motion formulas that we were looking at. So horizontally, x equals t times v naught cosine theta, and vertically, y equals t times v naught sine of theta minus 1/2 gt squared plus h naught. Okay, so t, of course, is time. So at any given time, I can find the distance that an object's moved horizontally or vertically. I can find its absolute position, which is what parametric equations are going to help us do. But what does v naught refer to? What does that represent? That's the initial velocity. That's how fast the object is moving. Theta, of course, is your angle of rotation. G is the acceleration due to gravity. So there's one of two values we're going to be using in here, and it depends on if you're given feet or meters. In this problem, we're using feet. So what will G equal? 32. 32 feet per second per second. Okay, is the acceleration due to gravity if you're in feet. Now, if the problem is talking about meters, then it is 9.8 meters per second per second. Okay, so I'm going to go ahead and let you know that because on your test Friday, I did put a problem like this. Could be feet, could be meters. It's one of the two. So we need to know what value of G is going to be represented there. Okay, what's H naught? That's how high the object was off the ground before it started moving. Okay, so let's see. A, will a bag thrown at a speed of 40 feet per second at an angle of 60 degrees go over the branch? Okay, so we're just looking for a simple yes or no. And I don't believe you guys took me up on it Friday. I think second period may have been the only one, but there are different ways that you can go ahead and work the problem. You can start with the horizontal formula and then use the vertical to help answer the question. Or you can begin with the vertical and then end with the horizontal. Typically what I like to do is go ahead and begin with the horizontal and end with the vertical. But before we even get there, let's identify all of our variables. Okay, like for example, what is V naught in A? That's the 40 feet per second. Okay, so this is the initial velocity. The angle theta, we're given that as 60 degrees. And how high is the bag off the ground before we throw it? 5 feet. So that right there is H naught. And we already said that G is going to be 32. So what I would recommend, and I just think it's a good strategy overall, identify the values of your variables, and then let's just start by plugging those into your formulas. So x equals t v naught cosine theta. I'm going to say x equals t times 40 times the cosine of 60 degrees. I'm just taking the information I have and I'm plugging it in. Remember, it's just a formula. Okay? I'm going to do the same thing for y, the vertical height. So t v naught sine theta, t 40 sine of 60. Now I'm going to subtract 1/2 32t squared. So what's half of 32? So I'm going to say minus 16 t squared, and then plus h naught it was 5 feet off the ground when we threw it. Okay. All right, now, like I said before, you can begin with whatever formula you'd like. I kind of tend to prefer starting with the horizontal, but sometimes it is better to start with the vertical. It just depends on the problem. Okay, so what I'm looking for basically is the amount of time it would take to go the 20 feet that I am from the branch. Okay, so I'm going to start by taking this x right here, and I'm going to plug in the horizontal distance that I am from the branch. So I'm going to say 20. So this is for part A, equals t times 40 times the cosine of 60. So you see how I have everything plugged in? This will tell me the number of seconds it takes to move 20 feet horizontally. Now this one, hopefully we don't need our calculator. Who can help me remember? What is the cosine of 60? It is 1/2. So half of 40? 20, and then if I divide by 20. There you go. So it only takes 1 second for this bag to go 20 feet horizontally. Okay, so t is equal to 1. All right. Well, now what am I going to do with that 1 second? There you go. Well, this top formula tells me the horizontal distance. The second formula tells me the vertical distance. So if I know it takes exactly 1 second to get to the 20 feet, well, at that time, how high is it off the ground? I'm going to plug it in here. So how am I going to determine whether this is a yes or no? Like, what am I looking for? There you go. If I have a height that's over 30, he'll make the branch and everything's okay. If it's less than 30, then we're probably going to have to throw it again. So let's see here. Because we're just plugging in 1, I'm not going to worry about saying 1 time. So I'm just going to go ahead and say 40 times the sine of 60. Okay, I'm going to arrow out of there, minus 16. Because, see, we had 1 times 40 times sine 60, minus 16 times 1 squared, but it doesn't change it. And then I'm just going to add 5. Is everybody okay with that? Second period actually wanted me to go back and plug in the 1s just so you could see it. Does anybody want me to do that here? Okay, so let's see. First attempt. So once it reaches the 20 feet horizontally, it's only close to 24 feet off the ground. So what are we going to put here? No, first attempt does not make it. It's a little over 6 feet short vertically. Okay. Well, now I'm just going to do the same thing, so I have different values. So I'm going to throw it a little harder, so it's traveling faster, and I'm going to throw it a little higher, 75 degrees. Okay. So I'm going to go back to my formulas here. 40 is now going to be replaced with 45, and instead of 60, we're going to plug in 75. Okay. And then I'm going to go ahead and do the exact same thing. Okay. So x equals, well, I still got the 20 horizontal feet, equals t times 45 times the cosine of 75. Well, this one we're going to need a calculator for, because you might even recognize cosine of 75. Do you remember that popped up a lot when we were doing sum and difference identities? Does that kind of seem familiar? Because we could break 75 into 35, or should be 30 and 45? Maybe, maybe not. It was a little after Christmas. Okay. So let's see here. Oh, let me go ahead and write out. So I would just go ahead and divide through by the 45 cosine 75. Because the 45s will cancel, cosine of 75s. Okay, so let's see here. Control divide. I got 20 over 45. This was a cosine 75. Okay, so how many seconds does it take to go 20 feet? Okay, so I'd say about 1.72 seconds, a little shy of 2 seconds. So a little longer this time because we changed our speed and height. Or, well, not height, the angle of elevation, I'll say. All right, so let's say t is about 1.72 seconds. So now what do I do with that? How does this help me get my answer? Yeah, just like we did for part A, I'm going to take this number of seconds and I'm going to plug it in here to tell me what the vertical height is at 20 feet from where we were standing. Okay, so for this one, we actually have to do it. So 1.72. Then we had 45 times the sine of 75. Okay, let's go ahead and get out of there. Minus 16 times 1.72 squared. and then we were going to add the 5 feet. Okay, so are we successful this second time? Yes. Okay. About 32.4 feet. Yeah. So it looks like we were able to clear it by almost 2.5 feet. Okay. So yes, the second time will work. Okay. How are these types of problems doing? Are they okay? All right. I didn't have it on as notes for the Google site, but I did give an extra problem like this in preparation for the test with the answer on Friday. It is on Friday's video if you wanted to take a look at that. Okay. Or several people took a snapshot of it. Maybe you can just get it from them. Okay. All right, good. That was the last focus activity. So sad. Okay. Now, we won't worry about doing it right now. What's that, man? I was just going to say, let's go ahead and finish. Let's wait to the end. I'm going to go ahead and stop about 15, 20 minutes early, let you work on your assignments. I can pass back some papers. That time, we'll go ahead and turn them in. Okay. All right. So here's our last unit, and we are just going to do the best we can to get as far as we can to help those people out who are going into calculus, because polar coordinates is something you're going to need to know. Okay, so you have graphed equations in a rectangular coordinate system. When air traffic controllers record the locations of airplanes using distances and angles, they're using a polar coordinate system. Now, the second paragraph here describes the rectangular coordinate system. We don't need that. We've been using it forever. So, let's talk about what's new. In a polar coordinate system, the origin is a fixed point that we call the pole. So we no longer call it the origin, it's the pole. Now, the polar axis is an initial ray from the pole, usually horizontal and directed towards the right. So for us, it's always going to be the same. You remember how with the unit circle, we had our coordinate system, we had x and y? We always started here on this axis, the positive x. What did we call that? We said we were starting in what position? Standard position. But when we're talking about a polar coordinate system, we're starting in the exact same place, but we refer to that as the polar axis. Okay, so it's no longer standard position. We call it the polar axis. Now, here's what a polar coordinate looks like. Okay, the first value is the length of your terminal side. That's the radius. Okay, the second value is going to be your angle measure. So again, if it's positive, you rotate counterclockwise. If it's negative, you rotate clockwise. Okay, but let me go ahead and do a quick comparison here. When you were talking about the good old XY coordinates, which one did you look at first? Obviously X, right? You always looked at it first. It told you to go left or right, whatever X was, and then Y was the second value, and that was vertical. But when you're talking about a polar coordinate where you have the radius and theta, you actually have to reverse that. You want to look at the angle measure first. Okay. Once you know where the terminal side is going to stop, then you find that length along the terminal side. Okay, so it's the reverse of a normal ordered pair. You always start with theta first. Okay, well, let's go ahead and try some of these. All right, now the only new information here is the last couple of sentences. It says if the radius is positive, then a point P lies on the terminal side of theta. If R is negative, then point P lies on the ray opposite the terminal side. Okay, so I'll explain what that means in just a second. So here is my polar axis. Let's pretend that this is what we would normally call the origin, but now we call it the pole. Okay, so this going straight to the right, what we would consider the positive x-axis, this is now the polar axis. Okay, so we're going to start here. Again, if theta is positive, then you rotate counterclockwise. If theta is negative, then you rotate clockwise. Okay, so let's take a look at point A. Right now, we're just kind of getting the idea, and then I'll go ahead and show you the polar coordinate system for the first time. Okay, so let's say I want to graph point A, which is at 2, 45 degrees. Now, still think of it, if it helps in terms of your XY axes, you still have the same 4 coordinates. Okay, Erica, what quadrant would 45 degrees be in? Quadrant 1, 2, 3, or 4? Quadrant 1. So let's say I go ahead and rotate 45 degrees, and I say that's the angle of rotation. So I go ahead and draw my terminal side. So it's on this terminal side that I go ahead and find the length of 2. So let's say there's 1, there's 2. So there would be point A in quadrant 1. You always rotate first, find where the terminal side's going to stop, and then find the length of that radius on it. Okay. Hello. Hey. Thank you, sir. Okay. Kyle. There you go, sir. Yeah, sure. Okay. So that's not too bad, right? Okay. Now, the second point, B, this is where it doesn't get more difficult. It's just very easy to forget. And this is where the very last sentence comes in. It says if R is negative, the radius, point P lies on the ray opposite the terminal side of theta. Okay. So let's do this. Negative 1.5, 2 pi over 3. Okay, Raphael, what quadrant is 2 pi over 3 in? That's in quadrant 2. Okay, so I'm going to start here at my polar axis. I'm going to rotate counterclockwise. So let's say that this right here is 2 pi over 3 radians. Okay, so now I'm going to go ahead and locate 1.5. So there's 1, there's 2, so 1.5. Now that would be the correct location if your coordinate was 1.5, 2 pi over 3. See, the radius is positive. If the radius is negative, you're going to find that length going in the exact opposite direction. So wherever 2 pi over 3 stops you, in the exact opposite direction, that's where you're going to go. So there's 1, there's 2, so that would actually be point B. It does work, okay? If the radius is negative, you point that in the exact opposite direction. So this point is not actually in quadrant 2, it's in quadrant 4. In fact, one main difference between polar and rectangular coordinates, in a rectangular coordinate system, one point, there is only one way to find that specific location. But when you're dealing with polar coordinates, there are 4 different ways to describe the same location. Aiden's like, I like this. Let's do it. Okay. Huh? Yeah, what? Yes? What? Well, it'll be okay. You know, chill. Because it's polar. Come on. You got till next Thursday, and then no more jokes from Mr. West. I know, right? Some of you are like, yeah, can't get here soon enough. They will still be available. Yeah. You know, having withdrawals. Okay, let's try this last one. 3, negative 30 degrees. Okay, so where would negative 30 degrees be? Quadrant 4. Okay, so I'm going to rotate negative 30 degrees. Okay, so here's my terminal side. Now, will I go in the exact opposite direction like I did on point B? Only do that if the radius is negative. So if the radius is positive, it's going to be found on the original terminal side. So 1, 2, 3, let's say that's point C. In fact, the way I like to think about a polar coordinate grid, have you ever seen a tree that's been cut down and then you looked at the stump? What do you see? You see a bunch of rings, right? You can actually use that to help you identify the age of the tree. Well, it's pretty much the same thing with a polar coordinate grid. You're going to have a bunch of circles going out from, remember, we used to call it the origin, now we call it the pole. So the innermost circle, that's a radius of 1. Then we have the second circle, radius of 2, 3, 4, and you can go out as far as your grid allows you to. Now, there is something else you can do. If you have a grid like this, but you have some points, maybe that contains a radius that's larger than what your grid shows, you can change the increments just like you would on a coordinate system, a polar rectangular coordinate system. You can count them by 2s, 2, 4, 6, 8, if that helps to fit your graph. And occasionally you may have to do that. Okay, so let's try these. So 3 points, P, Q, and R. I want to go ahead and plot these in my grid. This is a polar coordinate grid. Okay, so right here, that's the polar axis. That's where we start from. And of course, the pole is right there in the middle. Okay, so I'm looking for point P. Where is 4 pi over 3? What quadrant? It's in the third quadrant, right? So I'm going to start here and I'm going to rotate all the way around until I find 4 pi over 3. Now you don't have to highlight it. I'm just doing this, for purposes to help you out. So I know that my point has to be somewhere along this line. Well, what's my radius? 3. So from the pole, I'm just going to count 3 circles out. 1, 2, 3. So right there would be point P at 3, 4 pi over 3. Is everybody kind of starting to get the idea? Okay. And one of the things we're going to do tomorrow is I'm going to show you how a single point can be represented in 4 different ways. Okay. Go ahead and practice that. So really this first lesson is just an introduction to the polar coordinate grid. Okay. Now, I'm going to give you a few seconds. Try to plot Q and R. Okay, based on what we did previously. So plot points Q and R, and let's see what you guys think. Okay, you got to admit, polar coordinates are pretty cool, right? Polar, cool. I won't give up. I'll keep trying. Okay, let me catch up with you on point Q. Let's say, Stephanie, what quadrant would point Q be in? Quadrant 4? Well, wait a minute. It says 150 degrees. But R is negative, yes. So I would rotate 150 degrees, so it'd be on this line here. So the fact that the radius is negative means I'm going to go in the exact opposite direction. You're right. So from the pole, I'm going to count 1, 2, 3.5. So Q should be right there. She's absolutely right. How many people got that right? Okay, good. Good, good. Once you get the idea, it goes pretty quick. Okay. What about R? Let's see. Shayna, what quadrant do you think point R is in? 1, 2, 3, or 4? It's not 1. Now, are you telling me or asking me? Say, it's 2, Mr. West. Say, it's 2. Be confident. Say, it's 2, Mr. West. Yes. There you go. Well, okay, yes. All right. So, yes, it is in quadrant 2. All right, now, how would I rotate? We'd have to go clockwise, right? So here's the thing. If you don't know how far to go clockwise, well, why don't we go ahead and find 7 pi over 6 normally? If I started here, I'd go halfway. But then to get to 7 pi over 6, see, I'd have to rotate 2 more lines, right? So I want to go that exact distance, but I just want to go clockwise. Okay. So I'm going to go ahead and start here. I have to go halfway, but then I got to go 2 more. So I've got to be on basically 5 pi over 6 or 150. Remember, what do we call the angles? There you go. I couldn't even get the definition now. We already knew it was coterminal. Good. Angle, different angle measures, but the same terminal side. But now I want 1.5, so I'm going to say 1.5. So it'd be halfway between the innermost and the second circle. Wait a minute. Why didn't I go backwards in the opposite direction like I did for Q? Because R was positive. There you go. Okay. Any questions? Anybody had previous experience with polar coordinates? No? They're not too bad, right? Right. Okay. All right. That's as far as first period got. I'm going to go ahead and stop there. So you actually have probably a good 18 minutes left. Okay, before the bell rings. It's not a lot, but I wanted to go ahead and give you some time to work on your parametric equations homework. It's due tomorrow. If you want to turn in your focus activities, now is an excellent time to do so. Remember, what room are we meeting in on Wednesday? 2101. Okay. I will be here in the morning for tutorials. I just may have to take off a little early because of paper exam 2. All right. Okay, well, let me go ahead and shut this down.